How's it going, Mr. Zatola? Back here again with another relative dating sequence of events block diagram. This is block number 5 in your Earth history packet. So let's get to it. All right. I always say take a look at the block diagram, look at it as a big picture. There's a couple of items I want to highlight and go over. First and foremost, can't miss this. Um, that's a fault. Uh, I always think it's important that you know which direction the fault went. So you could just match up patterns. For example, there's B and there's B. So this one clearly went down and this one clearly went up. Notice that that fault cuts through that dark line. Okay, so what is this dark line? This dark line represents an unconformity of some type. And look at that. It has been cut by the fault, which tells me that fault, well, probably came after it. And looks like that fault goes through every layer. So it seems that the fault might have come last. But we also don't want to forget about our little dude here. Sure enough, he's at the Earth's surface. And this is definitely an erosional pattern at the Earth's surface, so we're not underwater. That should be noted. And the last piece here that I see that I want to highlight is these layers have been folded. But notice that the folds were before the fault. The folds happened, the fault shifted them. The easiest way to look at that, if I just take out some of my mess, if we take a look at this piece here, let's look at that layer and this layer. Clearly, this one is shifted down and this one is shifted up. So that fault came after those layers. Okay. So, quick zoom out. This one's a tough one. There's a lot going on here. Okay. So I'll try my best to, I think what might be better is that I go back and forth between the two. So what happened at the beginning? Well, let's take a look right here. What happened first? Well, I have layer G at the bottom, then layer D, then layer F, then layer E before that unconformity. And I look over here in the patterns, and here's my G, here's my D, here's my F, and yes, there's a little piece of E here and there. So G, D, F, and E. So here we go. We would say deposition. And what you're going to notice is as you get further into these and you get better at them, you don't have to put as much down, but deposition of, oops, I almost forgot the G, D, F, and E. Great. G, D, F, and E. Okay, and we know that these are in that order because of superposition. Okay, G is the oldest, E is the youngest in this situation, right? So G, then D, then E, then F. Okay, so we've laid down those layers. Now, what's gone on? Well, it looks like we laid down as layers, which were originally horizontal. All right, original horizontality, sedimentary rock layers. And then something happened and they became folded. Now, faulting and folding doesn't have to be during an uplift event, but just so you know, after the folding, it looks like we had this unconformity. So there's a good chance during uplift of that unconformity we had folding, but one of the things about sequencing is you can't be 100%. You weren't there and there's no record. So I like to keep it simple, and I would say folding. And then we enter our unconformity, and our unconformity has 3 pieces to it. We have uplift, erosion, and since there are horizontal layers on top of this unconformity, we went back underwater for more deposition, so subsidence, okay? And that's our unconformity. And that leads us to the green line I showed you there. So what happens after that? Well, it looks like we have layer C, then H, then B, then A. And you can relate them like this. There's C, H, B, and A also here. So it appears that that fault cut those 4 layers after they were laid down also. So the next piece would be depot of C, depot of H, depot of B, and deposition of A. And again, those are all because of superposition. Well, at least the reason I know they're in that order is because of superposition. C is older than H, H is older than B, and B is and B is older than A, leaving A as the youngest. And sure enough, A is at our top. Now what's happened? Well, so this is where an experienced geologist would look a little deeper. But it appears that during an event, there was a fault. Okay, this is a faulting event. Now, because I know that this man is standing on the surface, there must have been uplift. Did that fault happen during uplift? Or did it happen before uplift? Or did it happen after uplift? Well, that is not for this level of earth science, but what we could say is fault, uplift, and then at the top, because it's exposed to the atmosphere, erosion. Sorry about the yellow. I know it's a little tough to see. So just some key points. Look, if you did those 2, flipped them, I'm fine with that. If you did those 2 and flipped them, if you said uplift, then folding, or uplift, then faulting, I'm not going to punish you on that. There's no way for us to know which one happened first, at least not at this level. A geologist would definitely be able to identify that, but always ending with our final event. And in this case, remember, this man's on the surface, and this is an erosional pattern right here. That's exposure to the surface. That's why erosion's our last one. So there's another block diagram for us. Some of you picky people might be saying there's anticline and syncline in here. Well, there is. Here's our anticline, and this is our syncline. And there's another anticline right here. Just for those who really enjoy block diagrams, as I do. Yes, that's weird. So this is the full set of events. It is not the easiest to see. I'm trying to make sure you get a good amount of it in there. And yeah, just hope everyone's well. And give a try on the next 2. The couple next blocks that come up are a little more difficult, but give a try. If you do complete a couple, submit them, and I'll be glad to give you some extra credit for it if it's good and accurate and it shows a good effort. But all right, be well, everyone. I'll talk to you hopefully in person sometime soon, but I'll see you on another video again. Have a good one.